All right, students, from our last video, we learned how to put things in scientific notation. Now, in these examples, you might not always put these in scientific notation, but we might as well go ahead and try. And with our first rule, remember, in all of the numbers, you want to make sure that the decimal is after the first non-zero digit. So in example number A, the first non-zero digit, left to right we read, is number 2. In example B, it's 8. Example C, it's 6, and example D, it's 5. So in example A, we see that this number is bigger than 1, and because it's bigger than 1, we'll be moving that decimal over to the left. So 25,000, we move the decimal over, sorry about that, 1, 2, 3, 4. So this would be 2.5 times 10 to the 4. So we moved it over to the left because this number is bigger than 1. We see that the exponent is positive. So it's a positive 10 to the 4th. In example B, we do the same, but we're going to apply now rule number 3. And rule number 3 is it's a number smaller than 1, and we'll be moving the decimal over to the right. So the power of 10 will be negative in this example for B. So we move it over 1, 2, 3, 4. So this number is 8.36 times 10 to the negative 4. And again, it's negative because it's less than 1. So if we look at number C, more than likely you would never put this in scientific notation because that's just to kind of limit the number of zeros you need to write out. 6.8, it's clean, you don't have to do it, but somewhere they might ask you to put this in scientific notation just to kind of trick you. So we already have the decimal after the first non-zero digit, so it's still 6.8, but the trick here is times 10 to what power would keep this 6.8. Now we can't put a power of 10 to the 1 because 6.8 times 10 to the 1, so 6.8 times 10 would be 68. You can't put negative 1 because that would be a 0.68. So what do? 10 to the 0. And the reason why it's 10 to the 0 is 10 to the 0 is 1, and 6.8 times 1 is equal to 6.8. So that's if you want to put this in scientific notation. D, it's another example where I probably wouldn't put this number under scientific notation, but if it was asking me to do so, I'd go ahead, move the decimal over. I'm going to the right one time. This number's less than 1, so the decimal will be negative. So this would be a 5.7 times 10 to the negative 1, again, because that is less than 1. We get that negative. So go ahead and practice this. Go ahead and put this on pause, put this in scientific notation, and then we'll walk through it. All right, I'm assuming that you put it on pause, you work these out, and you're checking the answers. We see for both of these examples, they're bigger than 1. Both of these problems are bigger than 1, so we're going to see that our exponents are positive. We move the decimal over in this first number, 1, 2, 3. This is 1.2 times 10 to the positive 3. Why is that? Well, really, this is 1.2 times 1,000, and 1.2 times 1,000 would be 1,200. That's how we get that number. For the second problem, we move it over 1, 2, 3, 4, 5. So this is 2.2 times 10 to the 5th. Again, both of these numbers are bigger than 1. That's why we have positive exponents. These next examples, are less than 1. So we're going to have negative exponents. So we're moving the decimal over to the right. 1, 2, 3, 4. So we get 1.032 times 10 to the negative 4. Over here, we move it over 1, 2, 3, 4, 5. So this would be 1.2 times 10 to the negative 5. All of these are in scientific notation, so we don't have to write so many zeros out. We'll be giving these zeros names when we talk about significant figures to help us identify the number of significant figures. But again, this is so we don't have to write so many zeros and really big and really small numbers. All of these numbers look good. The only thing that they're missing is a unit. We'll also talk about that with measurements. But I hope this video helps. Please, if you have any questions, leave them in the comments, or you can email me directly. And I thank you for tuning in and paying attention.